All right. So, hello and welcome everyone. I hope I'm audible to all of you. So, welcome back to this amazing platform of QT learning. And today we're again back with another important concept of integrals. All right. So, as of the last lectures, we have been discussing with integrals and we were learning about the different methods of solving an integral problem, right? So as for the contents as concerned, we have already started and learned about the integration by substitution. We learned about integration by parts. We also started with learning the integration by using partial fractions, right? So today in this class, we are going to solve some questions on partial fractions, and we're going to also learn about different strategies and even indirect integrals as of this particular lecture is concerned. Okay, so if you're in this particular channel, I would request all of you to please subscribe to the channel and click on the bell icon to never miss an upcoming notification that you're going to receive, that whenever I'm live, you're going to get a notification, and that basically thinks and says that you should join the class live. Because if you watch the class live, it will be very easy for all of you to basically get started on the things, and maybe if you have a question, you can always ask the question in the class. Right, so that's about the bigger picture, and let's get started. Okay, so before I start, another quick announcement for all of you is that we have already started our live online batches. So as you can see of this poster over here, this basically if you need a maths tuition for JEE Mains and JEE Advanced 2026 and 27, if you're someone in class 11th and you're in class 12 and you want to start with your JEE Mains and advanced preparation, and you're basically comfortable more in online mode of preparation, then you can definitely contact us on this particular number. The number is on the screen, so please contact us on this number, okay, to get connected with me or my team. Okay, so if you want personalized mentorships or basically doubt clearance, and you basically need to cover a lot of topics in your chapters, like you are lagged behind in your curriculum in your classes, and because of which you basically have too much of backlog, then definitely these sessions are, or those one-on-one tuition is going to help you a lot in clearing those backlogs. So we are also coming up with basically specific chapters where we are basically training students for those specific chapters of specific topics that you have missed up in your classes. Okay, so those are basically called backlog clearance classes, and you can definitely see the advertisement for those classes in the YouTube channel. Okay, also in the shorts you can also see some of the demo videos where we're basically showing you that we are basically starting this those live classes where basically you just pay some 149 rupees and you get one chapter that has the backlog. Okay, so the advantage of basically doing is that you get to access the chapter that has already been, like, you haven't been able to clear the chapter, so we will help you out to clear the chapter. All right, so with this, and if you're interested into these monthly batches and you want to take a one-on-one tuition, the prices are starting just as 999, and it will cover your physics and your chemistry and your maths, everything, right? Also, if you want to learn for free, you can always watch us on free on this YouTube live platform, because every day we are coming live on this practical platform, and it's not only maths, it's basically chemistry, it's basically physics, it's basically biology. It's gonna be also on this channel, right? So don't forget to hit the subscribe button and click on the bell icon to never miss any upcoming notification, right? So with this, let's get started. So as of the previous lectures are concerned, we have already learned about integration by parts, and this was the basic theorem that you need to understand integration by parts, right? Also, you can see the announcement for the concept booster courses, that basically the topic is electrochemistry, and for maths is differentiation. So the date is starting at 14th to 19th of July, and the time is basically 8 p.m. Okay, so if you want to get it this classes, so the fee is just rupees 149, just 149. Contact us on this particular number. All right, so with this, and if you recall the integration by part, this was the basic theorem of it, and we then understood how this theorem comes about, and we also understand how to choose or how to label that which function should be choose in the first and which function should be choose in the second function, right? So this was the nomenclature that you need to follow while choosing your first function and the second function, right? And with this, we went on to solve some questions. So we did a lot of questions, okay, and then I gave you some homeworks. I hope you have done it. Okay, and then we also learned about different forms of integrals of these forms, and different forms of integrals. Also, we learned how to solve integrals whenever you have a specific form of integrals. The answers are very simple, right? So apart from them, we also learnt about some of the integrals of e to the power ax sine bx, and or e to the power ax sine cos bx, right? Those kinds of integrals, and we introduce a simple idea of Euler equations to simplify and get the result. So sometimes these Euler equations are very useful, especially in order to solve questions which involve sine and cosine terms as well, right? So this was about the topics that we have learned so far, and also we solved some IITG previous year questions, and then we moved on to learning partial fraction. That is some important topic that we learned in the previous session. So in partial fraction, we learned that if we have any rational function like f of x upon g of x, we can express that in terms of some simpler rational functions. That is something like for example, what we did, and we understood that when whatever function is given in the denominator, we express that in terms of, or factorize in terms of, some linear functions. Okay, some linear functions over here, and then based on that we basically separate it out based on the partial fractions, and there were different methods to try to find out those partial fractions. So if if the denominator is a linear factor, then the partial fraction in the numerator is going to be constant, and if your denominator in the partial fraction is going to be a quadratic term, then we have learned that the numerator in that partial fraction is going to be a linear, so it's just a 1 degree less, right? Also, we learned that if I have the degree of the linear factor as k, or it is repeating k number of times, so we also learned how to express those kinds of equation or those kind of partial fraction things, right? So that was all about what we have discussed in the previous class, and then I went on to give you this homework problems, right? There were 4 homework problems that I wanted all of you to solve on these questions, and I hope you have solved these questions. If you have solved this, please let me know, and we can quickly look about the solution of these problems. Please let me know if I have solved these questions or not. Okay, so let's quickly go through the solution of these problems. Okay, so if you look at the first problem over here, and let's quickly go through the solution. So this problem is like integration of 1 minus x square upon x times 1 minus 2x, right? So then we have dx, right? So before I start to solve this, I see that this is a basically simple rational function over here. So what I try to do is try to get it in terms of some partial fractions. So what I will do over here is that I will assume, so if you remember the partial fraction steps, is like we are already provided with the linear factors in the denominator. So it's like x multiplied by 1 minus 2x. So I can represent it in terms of, so it will be simply as, so what I can do is further is that I can also split this as half, so sorry, 1 upon x, right? So some over here, if you look at this question, and this is basically like some a by x and plus some b by 1 minus 2x. Okay, so we can write this in terms of a by x plus b by 1 upon 2x, right? So that's what we separate out in terms of partial fraction, and then if I simplify to get the value of a and b, then we have 1 minus x square is equals to a times 1 minus 2x plus b times x over here, right? So from this, if I try to compare the results, but the thing is like we are missing out one factor is like 1 upon half. Okay, so this will be like times of x into 1 minus 2x by 2. Okay, so this will actually produce the terms over here as follows. So if I just put x equals to 0 in this entire equation, then I will get the value. So I will get the value, that is, so if I put x is equal to 0, then from there I will get the value 1 is equal to a. And similarly, if I put x equals to 1 by 2, because that is when this factor, the 1 minus 2x, becomes 0, so then I will get the value of sorry, so then I will, over here I will get the value as follows. So I will get 1 minus 1 by 4 is equals to b times 1 upon 2, right? So therefore from here I'll get the value of b as 3 by 2. So therefore I can split this entire partial fraction in terms of, so the integral will now become, so 1 minus x square divided by x into 1 minus 2x dx. So this will become integral of 1 upon 2 plus 1 upon x plus 3 upon 2 times of 1 minus 2x, right? So this is what it becomes now, and then dx, right? So therefore what I can write this, so therefore I can easily integrate individually. So this will become 1 upon 2x plus natural log of x plus 3 by 2 times of natural log of 1 minus 2x, and then divided by minus of 2 over here, plus some constant c, and that's going to be the answer for this question. So the question answer is basically x upon 2 plus natural log of mod of x minus 3 upon 4 natural log of mod of 1 minus 2x plus some constant c. So this is what the result will look like. This is the result of the integral. I hope this is clear to all of you, right? So this was the solution of the first homework problem. Okay, so you just have to simply try to express this fraction or simply the rational function in terms of the partial fraction. I hope if you try to do it on your own, it is very simple, right? So if I again look at the other homework problem, so I won't be solving the entire problems, but I will give you the hint on how you can approach the partial fraction. So if you look at the second problem, the linear factor x minus 2 is basically repeating 2 times. So this partial fraction can be separated and written as in terms of, so it will be like a by x minus 2 plus b by x minus 2 whole square. Okay, so this is how you have to represent this partial fraction. And similarly, if you look at the third problem, the partial fraction over here will look like a upon x plus b upon x square plus c upon x plus 2. Okay, and if you look at the fourth problem, the partial fraction of this problem is going to be looking like a upon x plus 2, and since x square plus 4 cannot be factorized further in terms of its real numbers, so therefore it has to be quadratic in the denominator, so it's going to be like bx plus c divided by x square plus 4 That's going to be the solution, right? So that's how you're going to separate these partial fractions, and then you get to the solutions of this a, b, and c. Once you get the solution, the questions is much simpler, and then it becomes a simpler integrals to solve for, right? So I hope this part is clear to all of you. If you have any questions, please let me know. Please let me know in case you have any questions. Hi, Arab Singh Chauhan. Okay, good morning. Yeah, good morning. Okay, is this part clear to all of you? Please let me know. Yes or no. Have you solved these problems? Anyone who has solved the problem and got the answer, please let me know in the live chat. Please let me know if you have solved the questions and got the answer. If you have solved the questions and got the answer, please let me know. Okay, I hope this is clear to all of you, right? Any questions, please let me know. So I'm expecting no questions, so let's go and learn about and solve some more questions on partial fraction, right? So today we are going to solve more questions on partial fraction, and we're also going to learn about some different techniques as well, right? So the first question I'm going to talk about today in our class is basically like, so let us say I have an integral. I have to integrate 1 minus x sine x whole divided by x times 1 minus x square 1 minus x cube over here. So 1 minus x cube, then I have e to the power 3 times cos x. Okay, 3 times of cos x, and that is my integral, right? So these kinds of questions are generally questions where you actually have to first of all apply the substitution method. Then you can see that how this questions becomes a question of partial fraction, right? So if you look at the problem over here, the problem is simpler if you try to think in the way the question is basically being asked over here. So what you can do, you can try to simplify and write this as terms as 1 minus x times of sine x divided by x times of 1 minus x e to the power cos x and whole cube of it, right? And then dx over here and dx over here, right? So this is what the integral will look like, right? Now, if you just try to understand this particular term, that is x into e to the power cos x. So if we assume this particular term as some constant, as some variable t, so let x e to the power cos x be some variable t, and if you then differentiate both the sides, and then if you differentiate both the sides, okay, then if you differentiate both the sides, it's gonna be like e to the power cos x plus 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 x times e to the power cos x multiplied with minus of sine x by chain rule, right? So therefore, and this is basically going to be dt, and also don't forget that there is a dx over here, right? So just substitution method I'm applying over here, right? Okay, this is equal to dt. So therefore, what I can check over here is that if I take e to the power cos x is common, it's going to be like 1 minus x times of sine x dx is basically equal to dt. So therefore, what you can see and observe over here, 1 minus e to the power sine x, 1 minus x sine x dx is basically nothing but dt. Okay, so what I can do is that I can substitute over here in this problem back. Okay, so if I just do the substitution, this is going to be like dt upon e to the power cos x. Now e to the power cos x is basically t upon x. E to the power cos x is basically like t upon x. So what I'm going to do over here is that so I think I'm pretty much doing the correct one. So just let me check once more. um, this is basically dt, so x e to the power cos x minus sine x plus, yeah, so yeah, okay, fine. So therefore, what we got is over here is that we have one more term. We have a term e to the power cos x that is basically going out, right? So e to the power cos x terms can be basically given as t upon x, right? So over here, if you look at, oh yeah, so over here this e to the power, so what I can write over here is that I can write this 1 minus x sine x dx as nothing but it is basically equal to dt upon e to the power cos x. Now since e to the power cos x can be written as t upon x, so this can be given as dt upon t upon x, right? And if you look at, there is one more x in the denominator which is going to cancel out because this is going to be equal to x dt upon t. So this x and this x is going to cancel out, and ultimately we will be left out our terms as dt upon t multiplied with, so multiplied with 1 minus t cube, 1 minus t cube dt, right? So this is a simple integration now we have to perform. Now if you look again over here, it is basically like becoming like a simple rational function. So again, what I'm going to do is that I'm going to split this rational function in terms of its partial fraction. How am I going to do that? It's a very simple and straightforward method. So over here, if I look at the fraction over here, the rational function over here is like 1 upon t multiplied with 1 minus t cube over here, right? So over here, if you look at, and I can factorize this further as 1 by t. Now 1 minus t cube can be factorized as 1 minus t multiplied with 1 plus t square, which cannot be further simplified or factorized. So therefore, this can be given as a upon t plus b upon 1 minus t plus plus, and since this quadratic cannot be factorized further, so therefore this will become ct plus some d divided by 1 plus t plus t square, 1 plus t plus t square. I hope this part is clear, right? So now the only task is basically to solve for the value of A, B, C, and D. So that is very simple and straightforward. So what I'm going to do is that simply I'm going to compare the coefficient. Okay. So I'm going to compare the coefficient. Okay, so if you just compare the coefficient on both the sides, so therefore on comparing the coefficient, you will get the value of A is equal to 1. You can easily do that by just putting T is equal to 0. So if you put T is equal to 0 and just ignore this T over here and you just put it, then the value of A is going to come out. Okay, so it's 1. So, and similarly, your B is going to come out easily when you put T is equal to 1. So B is going to come out as 1 upon 3. And similarly, C is going to be like minus of 2 upon 3, and your D is going to be like minus of 1 by 3. So minus of 1 by 3 is going to be the value of the D. So therefore I got all the coefficients now. Okay, therefore I got all the coefficients, and therefore my question is much simpler in terms as that I can represent the given integral. Now I can represent the given integral over here in terms of integration of, so the integral over here will be like dt upon t plus integration of 1 upon 3 by 1 minus t dt plus integration of, so minus I'm taking it common, so 2 upon 3 divided by so 2 upon t plus 1 upon 3, and then divided by 1 plus t square, and then dt. So this is now the new integration which becomes, so therefore the solution is very simple. So the integration is going to be like natural log of mod of t plus 1 upon 3 natural log of 1 minus t, and then a minus 1 over here will come out, so minus 1, so this will become minus, and then this is like a minus 1. And now if you just look over here, this solution, so if you just differentiate this, so 1 upon 3 can also come out as common, and then if you differentiate this, the expression is going to be like the 2t plus 1 dt, right? So therefore this is also going to be a natural log of 1 plus t square. Okay, 1 plus t square, which is already positive, so it doesn't matter if you put a mod or not. Okay, and some plus some constant. Now ultimate goal in our substitution method is that we have to substitute back into the original equation, that is x, right? So if you just substitute back in terms of x, the solution is going to look like, because t is basically x e to the power cos x, right? So t was x into e to the power cos x, so we have to just put it back over here, and the solution is very simple, and therefore we have the solution as natural log of mod of e to the power cos x into x minus 1 upon 3 natural log of 1 minus x into e to the power cos x, and then we will have over here minus 1 by 3 natural log of 1 plus x times of e to the power cos x plus over here will be like x times e to the power cos x whole square, right? So, and then plus some constant c. I hope this is clear to all of you, right? So this is going to be the solution. Is this clear? Please let me know this problem is clear or not. Okay, I assume this problem is clear to all of you, right? Please let me know if this problem is clear or not. Any questions? Any questions, anyone? Please let me know if you have any questions. Okay, I can help you out with the part where you're not able to understand, right? Okay. And please share this video among your friends and your relatives. Okay, so whomever basically needs this video, and you can think that video can help them prepare for their upcoming JEE preparation or upcoming school examinations, please share these videos to all the people. Okay, so that you are actually helping me out, because I'm not charging any money for this particular sessions. Okay, so you can help me by spreading this content among your friends and your relatives. Okay, so that they can also get access to these live lectures or these free live sessions. Okay, I hope this is clear and makes sense to all of you. Please just let me know if you have any questions so that I can discuss about, or else we can proceed with the next set of topics, because we have to basically also work on understanding different sets of questions as well, right? Okay, so if this part is clear, let's move to the next problem. And next problem is another very interesting problem where you're going to use the collection of the previous topics that you have studied, right? So the second problem that I'm taking up is basically integration of, you have to integrate sine of 4x e to the power tan square x, sine of 4x e to the power tan square x, okay, e to the power tan square x. I hope this is clear, right? E to the power tan square x and then dx, right? So we have to basically simplify this particular integral so that we can solve it. Now this is a very interesting problem in itself, and you have to basically try to think of applying the trigonometric identities before you actually proceed for the actual solution of this, right? So if you look in the problem over here, what I can first of all think and simplify is that, is there any way I can assume the tan x as some t and then I can proceed with it, or maybe tan square x as t and then I can proceed with it, right? So if I look at tan square x as some variable t, and if I differentiate both the sides, I should have 2 tan x secant square x dx and equals to dt, right? So if you look at the sine 4x over there, it doesn't feel or make sense that to basically approach the question by assuming tan square x as some t. So what should we do? Rather, what I can observe over here is that we have a multiple angle formula over here of sine 4x. So we can split this up and write it as 2 times of sine 2x into cos of 2x, right? Into cos of 2x, which I can further simplify, and again sine of x can be, sine 2x can be again further simplified at 2 sine x cos x. So therefore it will ultimately become, is going to be ultimately becoming 4 times of sine x into cos x into cos of 2x, and then I will have e to the power tan square x, and then I will have e to the power tan square x, right? I hope this is clear to all of you, right? So it's pretty simple, straightforward. Now the question becomes more interesting, that if I divide this is by cos x and then I multiply with cos x, so this becomes cos square x, right? And the advantage of doing this is that I can make this as tan x, which I needed it. So therefore this will become 4 times of this will become tan of x over here, and this will become cos square x, right? And also I can further simplify the cos 2x as cos square x minus sine square x, right? So the advantage of doing that, again you will see over here, is that so it will become cos square x, and then I can write this as cos square x minus sine square x, and then we will have e to the power tan square x, right, dx. Now, the advantage over here is that, now please try to understand, these kinds of methods are very, very useful, especially when you are solving questions and you are getting no clue on how to prefer or how to approach this question by substitution method. So over here, from this particular solution, what I can do is that I can take a one more cos square x. So if I take one cos square x common from this factor cos square x minus sine square x, so I can make this as, so this becomes tan x, and this will become cos to the power 4x multiplied with 1 minus tan square x, and then we'll have e to the power, tan square x and dx. This will be the simplified version. And the advantage of doing is, over here you can try to understand that this cos to the power 4x, if I take it in the denominator, it becomes 1 upon cos x, which becomes secant x, right? So I can simply replace that with the secant term. So this will become 4 times of integration tan x upon secant square x and whole square of that, and multiplied with 1 minus tan square x, and then we'll have e to the power tan square x dx, right? I hope this is clear, right? So what I'm trying to get is that I'm trying to assume tan square x as t. So therefore now if I assume tan square x as some t, therefore it will need only 2 times of tan x multiplied with secant square x dx, it will become equal to dt. So the thing over here is that, therefore my integral will now become 4 times of integration of, so this tan x, and so this tan x times secant square x, right? So secant square x can be made, if I try to write over here, that is 1 plus tan square x and then minus 2 times of tan square x. So what will happen over here is that this will become 1 minus t, this will become 1 minus t, and then we'll have e to the power t, and then we'll have dt, and then the denominator will become, so secant square x, so secant square 1 plus tan square x and whole square of that, and that will become 1 plus t, and therefore whole cube, because one more cube is going to be there, which you don't need to forget, because the secant square x, because I have this tan x dx in the numerator, so this become 1 minus t, e to the power t, and this tan x dx become dt, so I'm writing it over here, so tan x dx becomes, dt upon secant square x, so tan x dx becomes dt upon secant square, which can be written as, so this can be written as dt upon 1 plus tan square x, so which is become dt upon 1 plus t. So this becomes dt upon 1 plus t. So this 1 plus t square and 1 plus t becomes 1 plus t cube. I hope this is clear. Now the thing is that we are basically getting a form of e to the power x plus f of x plus f dash of x. That kind of equation is basically now becoming. So therefore, we have direct solution for this. So what I can do over here is that, oh, I don't forget the 2 over here. So this will become not 4, this will become 2, because already there is 1 2 over here, right? So this will now become, this is equals to 2 times integral of, so this will become integral of, so if I take e to the power t as common, and therefore I can make this as 2 times minus 1 plus t, and then, oh, okay, so what I'm going to do is that I'm going to separate this numerator in form of f of x plus f dash of x, so then I divide by 1 plus t whole cube over here and dt, so this will become now form of, so this is going to be a form of 2 times. So what I'm trying to do is that I'm trying to make it of e to the power x plus f of x plus f dash of x, like this kind of form. So that if I take integration of that, the result is very simple. That is e to the power x multiplied with f of x, right? So what I'm doing over here is that e to the power x, and then if you write this 1 upon 1 plus e and whole square of it and minus with it plus 2 upon 1 plus t whole cube will become the derivative. So this is f, and this is f dash, right? Simple. So therefore your solution is going to become equals to, so your solution is going to be equals to 2 times e to the power t minus of 1 upon 1 plus t whole square, simple, plus some constant c. And therefore our ultimate job in substitution is basically to substitute back in terms of x, and therefore the solution is going to be like 2 times e to the power tan square x, okay, and there's a minus, don't forget it, divided by 1 plus tan square x and whole square of it plus some constant c. I hope this is clear to all of you. So which can be further simplified as, so 1 plus tan square x becomes secant square x, and you can further simplify, so this will become 2 times of, so 2 times of cos to the power 4x into e to the power tan square x plus some constant c. I hope this is clear, right? So this is the solution of our integral problem. I hope this is clear to all of you. I assume this is clear to all of you, right? Please let me know in the live chat it is clear or not. Please let me know in the live chat is it clear or not. So with this, I would like to give you some homeworks. Okay, with this I would like to give you some homework, and if this question is clear, I don't think that you will have difficulty in solving the homework problems. The first homework problem that I want to give is that try to integrate dx upon 1 plus x cube, dx upon 1 plus x cube is a simple integration. Just try to do it by parts, right? The second integration I'm going to give is that try to integrate tan inverse of x upon x square. So this is going to be an interesting problem, and try to think of it. Okay, try to think of it, how you can apply the substitution, and then you can think of applying the by parts. Sorry, the partial fraction. The third problem I want to give is that try to integrate tan x plus tan cube x whole divided by 1 plus tan cube x. Okay, so these are the 3 homework problems that I want to give all of you. Please try to solve the 3 homework problem and let me know the solution in the comment sections. Okay, after the live session is over, and also we can discuss about the solution of these questions in the next upcoming class. Okay, Jai Chaudhary. That's great. Okay, so I hope these questions are clear and making sense. So this is the ultimate idea that you need to understand in integrals problem. So not all problems will be straightforward. So sometimes you have to think of how to apply the substitution, and then you can think of other methods of integration. So that's the combined questions that you're going to definitely see in JEE Mains, in JEE Advanced, and any other competitive examinations of engineering. I hope this makes sense. And with this, we would like to conclude our class over here. Thank you for your attention. Have a nice day.